Hi, my name's Patrick. I'm the SVP of Technology here at FeatureBase, and I just wanted to share with you some stuff we're working on in the engine room to enable more customers to do more stuff with FeatureBase. So this is some stuff that's not quite out yet, but we just thought we'd share and give you an idea of where we're heading. So one of the things that we've always talked a lot about here at FeatureBase is, or wanted to do, is have this idea that we can bring the model or the execution of the model to the data rather than take the data and execute it somewhere else. So for us, we've been toying with this idea of stored code, and I want to show you what we can do now in FeatureBase. So here's an example here of a user-defined function, if you like, that's actually expressed in Python language. And this is a good way to bring a whole wealth of existing Python code into FeatureBase so you can take advantage of the functionality that it provides. In this particular case, I'm using a BERT model to do text embeddings. So this function takes a sentence, a piece of text, and returns a dense vector. And you can see that there are all the sort of things that you'd expect to see from a user-defined functions perspective. So I can drop the function, and if I do a select star from functions, we'll see we had no functions, and I'll go ahead and create this function, and then now if I do a select from the system table from FB functions, you'll notice there's my function. It's in Python language. Here's the body. It returns a vector 768, and there are the parameters so that we can do type checking. And so let's actually test that and see what happens when I run it. So I'll embed testing, and if I run that, it goes off, shells out to Python, and returns something that looks suspiciously like a dense vector. And why is this cool? Well, if you've been keeping up with current events, and you would have heard a lot of press lately and a lot of buzz around this idea of large language models, OpenAI and ChatGPT and Google Bard and what Microsoft are doing. And what these transformer models do, in fact the transformer model that I've wrapped in this Python function is that it represents text as a series of numbers. And then what you can do is if you have two different pieces of text and you have the two different and you want to know how related are the concepts in those two pieces of text, if you embed them, right, or you generate these dense vectors, which is a term called an embedding, you can do a similarity calculation to find out how far apart those pieces of text are in some n-dimensional space, and then and you can find out whether how closely they relate to each other. So in order to take advantage of that in FeatureBase, we've implemented some vector scalar functions. So we have cosine distance and Euclidean distance. You can see here I'm just running it with some very low dimensionality vectors here, just to give you an example of what you'd expect if you run those two functions. So how do we put all this together and turn it into something useful? So I have a table, or I want to go create a table. I want to create a table, and I'm going to store some hobbies in it. And my example here is I'm going to store a sentence about the hobby. I'm going to embed the sentence to get a dense vector, and I'm going to add some categories just because I can. And interestingly enough, if you're not already using this in professional life, if you're part of a software engineering team, this is the prompt I used, let me get this result window out of the way. This was the prompt I used with ChatGPT to generate basically this insert statement. This is like magic, and another area why this idea of large language models and text embeddings is so interesting. So I ran this prompt and I got this test data, and you can see here, each row is an ID, a sentence about a hobby. I'm going to embed the same sentence, and then there's some categorization information. And so if I run that, I've already actually done that. If I do a select star from hobby, you'll see that there's my data there. There's my ID and my sentence, my big long list of numbers, and way over here on the right hand side is the categories. And so what can I do with this, right? If I have some text data and I embed it, what can I do with it? Well, I can do some similarity searches. So I can say, if I have the phrase gamer chair, right? What's the hobby that's closest conceptually to that? And so I'm just using a cosine distance calculation here, and I'll just run this query, and it'll take a couple of seconds. So it's embedded this and then worked out what the distance between all of our hobbies is and gamer chair. And unsurprisingly, right at the top is that if you've got a gamer chair, then you're probably going to be playing video games. And lo and behold, that's the thing with the closest distance. Interestingly enough, chairs and reading aren't that far apart conceptually either, and so that's one way in which vectors and similarity calculations are used. Let's try something else. What about flowers? So this example here, I did the embedding in line, but let's assume for a minute that I already have a vector, right? So you can see here, if I embed the word flowers, I get a value that looks like that. And actually, I just copied that 0.05598, so on and so on and so forth. Yes, that looks the same. So here's my vector here, and if I run this query, you'll notice that flowers is probably pretty closely related to gardening, and also there's a good chance that flowers are going to be in paintings of landscapes, and probably traveling to new places as well. And photography seems to be related to everything. It's interesting to see photography generally tending towards the top of the list in similarity searches like this. Anyway, this was a brief example of just some stuff we're starting to add to FeatureBase to sort of tie a lot of this stuff together and make it very, very easy to work with this stuff. We now have user-defined functions that can be expressed in Python. SQL is coming. We are still working on making this secure and sandboxed, so we don't effectively ship a root exploit into our database. So user-defined functions. Once it's a user-defined function, it can be used anywhere where a SQL expression can be used. So in queries or in ingest transformations or any of that sort of thing. We have some inbuilt cosine and Euclidean distance functions. These will be accelerated with vectorized compute, and then putting it all together, you can see that here's a practical example of how all that can be used. If you have any questions about any of this, feel free to reach out, and I hope our users can use this and get some value out of it. Thank you.